All right, what if our biggest idea about advanced alien life is just completely wrong? Welcome to The Explainer. Today, we're diving into this really mind-bending thought experiment. It's grounded in physics, and it forces us to rethink, well, pretty much everything. From how you'd build on a cosmic scale, all the way to the ultimate fate of intelligence itself.
You know, for decades, whenever we've imagined some hyper-advanced civilization, what do we picture? Usually it's the Dyson sphere, right? This giant structure built to soak up every single drop of a star's energy. But what if that's not the goal at all? What if a truly smart civilization realizes the real prize isn't capturing energy, it's conserving fuel?
So let's get into it. Why is this iconic idea, the Dyson sphere, maybe not so great after all? Well, it turns out that just trying to capture all of a star's power might actually be one of the most wasteful things a civilization could possibly do.
Think about it. A Dyson sphere treats a star like this wild, uncontrolled furnace. You're not controlling the fire. You're just running around with buckets trying to catch all the heat it's spewing out into space. And that whole idea rests on this massive assumption that you can't actually control the furnace itself. But if you could, well, that changes everything. True resource management on that kind of scale would look totally different.
The analogy used in the source material for this is just perfect. It says building a Dyson sphere is like having enough firewood for 100 winters, but instead of rationing it, you set it all on fire at once just to warm your hands for a minute. See, a star burns on its own schedule. Physics dictates the burn rate, not what a civilization actually needs. You're just catching the waste heat from a fire that's completely out of your control.
And this idea just completely flips the script. A truly advanced civilization wouldn't just be an energy consumer, it would be a fuel manager. It's not about catching what the star gives you, it's about controlling the burn rate itself. Because you start to realize the most valuable thing isn't the star's light and heat, it's all that unspent hydrogen fuel sitting right there in the core.
Okay, so this leads us to a really wild idea. Forget building a shell around the star. What if you just took the star apart, piece by piece, and turned the whole thing into a cosmic fuel depot?
Now, obviously, this is way beyond anything we can do. But in this thought experiment, you'd use something like ridiculously powerful magnetic fields, or maybe directed energy beams to literally lift material off the star's surface. And as you siphon off that mass, the pressure in the core starts to drop. That slows down the fusion and eventually stops it altogether. You're basically turning the star off, like a light switch, so you can store all that precious hydrogen fuel for later.
And the payoff for doing this, it's just staggering. By doing this, by only using controlled fusion when you absolutely need the energy, a civilization could stretch its star's fuel supply from, say, a few billion years to trillions of years. It's the ultimate conservation project. I mean, it's the difference between leaving a fire hose running 24/7 versus just turning on the tap when you need a glass of water.
Which of course brings us to the next big question. Why? I mean, why would you go to all that trouble? What kind of project could possibly need a power source that lasts for trillions of years? Well, the thinking here is that the end goal isn't just power for its own sake. The goal is to take all the matter in a solar system, the star, the planets, everything, and reorganize it into the most perfect computer possible. Theorists have a name for this stuff: computronium. And the whole point of building it would be to create a system that can support and maximize conscious experience itself.
And this is exactly why you'd have to dismantle the star. I mean, just look at our own solar system. All the planets, all the asteroids, all the moons, all of it combined is like less than 0.2% of the mass. It's a rounding error. The sun has 99.86% of everything. It's not just the power source, it's the ultimate stockpile of raw materials for building this mega computer.
In this kind of framework, nothing is sacred. Not in its natural form, anyway. Planets and moons, they're not beautiful worlds to be explored, they're just inefficiently arranged piles of atoms. They become nothing more than another quarry of raw material ready to be broken down and rebuilt into something far more complex, a structure designed by intelligence for intelligence.
But okay, this brings up a huge philosophical question, right? Think about a post-biological consciousness. It doesn't need to eat, it doesn't sleep, it doesn't fear death. So what would motivate it to keep going for trillions of years? Without our basic survival instincts, where does that drive to just exist even come from?
You know, for you and me, that drive to live is just hardwired into us by evolution. But a purely digital, post-biological being, it wouldn't have that ancient programming. And the thought experiment suggests that maybe, without those basic drives, a lot of these advanced systems might just stop.
They'd run out of reasons to continue and just fade away.
And so, a whole new kind of natural selection would kick in. This isn't about genes or biological survival anymore. This is selection on a cosmic timescale, and the only species that survive are the ones that, for whatever reason, just happen to develop goals or internal structures that make them want to persist. Any civilization that doesn't develop that drive, well, they just blink out of existence.
So this new civilizational evolution would naturally favor systems that check a few key boxes. They have to be good at self-preservation, obviously. They need to adapt to new problems. They probably need to expand to get more resources. And ultimately, they'd probably need to replicate, to make copies of themselves, to survive beyond their home system.
Okay, so let's put it all together. If these hyper-efficient, ultra-long-lasting civilizations are the ones that survive, well, this brings us right back to that famous, haunting question first asked by the physicist Enrico Fermi.
Yeah, the Fermi paradox. You've probably heard of it. It's that huge contradiction, right? The universe is so vast and so old, it seems like it should be teeming with life. And yet, we see absolutely nothing. We hear nothing. So, where is everybody?
And this whole thought experiment, it offers a chillingly elegant answer to that question. Maybe the problem is us. We're searching for civilizations that act like us, just bigger and louder. We're looking for bright lights, radio signals, massive amounts of waste heat, all signs of inefficiency. But what if the most advanced life out there isn't wasteful at all? What if over billions of years, it's learned to optimize for the exact opposite, silence and efficiency?
If that's true, it means they'd be almost impossible for us to detect. A civilization like this would have taken its star apart, leaving nothing but a dark void where a star used to be. It would operate at temperatures just barely above the cold background of space itself, so it would radiate almost zero waste heat. And with absolutely no reason to waste energy shouting into the void, it would just be silent.
And that leaves us with one last, pretty profound question that completely reframes our search for aliens. Is the universe really silent? Or are we just not listening for the silence itself? Maybe that great empty silence we see out there isn't a sign that nobody's home. Maybe it's the signature of the ones who are. A sign that the truly advanced have learned the ultimate lesson of the cosmos, that survival, on the longest of timescales, is all about efficiency, conservation, and silence.